This is just a short video introduction to tonal analysis and determination of tones of environmental noise using the XL2 and the Data Explorer PC software. So as you know, let's pull up an XL2. Part and parcel of the basic XL2 functionality is the FFT function. So in identifying the presence of tones or identifying a frequency signature, then of course the XL2 will measure and store that as we're looking at the moment. So here's my 1 kilohertz whistle, but of course this doesn't give us any tonality calculation as such. It just gives us a frequency spectrum where we can identify the tone, maybe the frequencies of the tone, and maybe even do a bit of frequency signature matching. So do a measurement close to a machine that you think might be the source of the tone, and then measure in maybe a complainant's property to see if the frequencies that are heard in the property correspond with those measured close to the possibly offending item of machinery. But having made measurements and stored audio recordings, which is the important thing, Data Explorer is where we would do our tone calculation. So this is a measurement in a property, or an illustration of a measurement in a property, where we have calibration tone at the beginning of the measurement and one at the end, so that you can see quite clearly that 94 dB, or the meter was reading 94 dB both at the start of the project and the end of the project, so we can safely assume the measurements in between the two calibration tones are of high integrity. The blue bars are the audio recording. So in this case, because it was in a complainant's property, or it may have been in a complainant's property, then the complainant has control of when to make a sound recording. If you were doing attended monitoring outside on a tripod, you would probably just continually store audio throughout the measurement period. So in this case, this is the audio recording for the commentary with the complainant, Mrs. Smith. The typical background noise, and then the noise nuisance, which I think in this case are not necessarily industrial. It's a variety of different types of recordings, but let's have a quick listen to each. So that's obviously dog barking. I think this one is DIY, and this one is music. But you'll notice that there is a calibration tone, like I said, a calibration tone here, but an audio recording associated with that calibration tone. So I'll click on that, but maybe just turn the volume level on your headphones or speakers slightly down a little bit. So we'll use that particular recording to do an FFT analysis on it to determine its tones, which is very very contrived, because we know it's going to be 1 kilohertz. But anyway, this is really just about showing you the process. So if we right click on that blue bar, we'll have a drop down menu, and one of the options on the menu is FFT and tone analysis, so we'll highlight that, and in this case it's going to do an FFT analysis on the entire audio recording. Now if we had done continuous audio recordings throughout maybe a 30 or 40 minute period, we would simply mark an event and then just do an FFT on the marked event, so rather than the whole audio recording. But in this case we'll just do an audio recording on this particular event. So if I click on calculate, that's the calculation. Let's just zoom into the area of interest, which is here. And here we can see there's our tone. Our primary tone is at 999 Hertz. The audibility is 81.6, and the penalty factor is 6 dB. You can see that the critical band start frequency is 899, and the critical band end frequency is 1098. So, and this is clearly indicated by the yellow bar. So again, we can maybe zoom into that a little bit more. So you can see where the critical band stops and starts. And for this particular tonality, or this tonal investigation, we've chosen the standard. In fact, I should have maybe done that to start with. BS4142 with a post weighting of A and a seek criterion of 1 dB. So likewise, if we wanted to do a tone analysis in terms of ISO 1996, we choose that standard, and we get a slightly different type of analysis. So Data Explorer supports both, but the one that seems to be quite popular and quite a useful tool is tone analysis in accordance with 4142. So having done our analysis, there's our measurement results. So we can right click in the table here, export that to Excel, which I'll do now. And now that opens up Excel with a summary of the tone candidates, or the various tones found, and the one that was dominant. So you can see the 1000 Hertz with a second harmonic at 2 kilohertz, and a third harmonic then beyond that. So that's the tonal analysis with the Data Explorer software.